All right, in this video, we're going to graph sine and cosine graphs by hand. And this time, we're going to add in some horizontal and vertical shifts, so left, right, up, down. So let's go ahead and write the equation y equals 3 sine of theta divided by 2 plus pi divided by 2. And we'll go ahead and leave it like that. All right, on this one, you can't quite see what the period should be because we need to factor out basically the GCF of what's inside those parentheses. So normally if you are given multiple shifts like this, you should see a number in front of the parentheses, and that number would tell you how to find your period. And in this one, it's not there because it's hidden inside the parentheses. So hopefully you can see that the two pieces inside the parentheses have like a 1/2 in front of them. You could think of it as 1/2 theta plus 1/2 pi. So 1/2 is actually the GCF. So I'm going to write y equals 3 sine of 1/2 times theta plus pi. All right, so the period of my graph, it looks like I should be taking half of 2 pi, but I do the opposite of that. So 2 pi times 2 is 4 pi. And then the amplitude of my graph is going to be 3. So what we're going to do first is we're just going to pretend that the movement here, this plus pi, that's going to mean that eventually we're going to move it left pi. We're going to pretend that that part of the problem is not even there. We're just going to go ahead and do the graph with the period of 4 pi and the amplitude of 3. And then once we have those 5 points drawn, then we can move everything left pi because it's much easier to do it that way. So if I want to draw a graph with a period of 4 pi and an amplitude of 3, I'm going to go ahead and say, I'm also going to keep in mind that I'm moving my graph left pi. So I want to make sure when I do my intervals that that's kind of easy to do. But I'll maybe say every 2 boxes equals pi. That would work out pretty well. So I'll do pi, 2 pi, 3 pi, 4 pi. An amplitude of 3, so I'll say, okay, it goes up to 4 down to -4. So I'm just going to draw the regular sine graph for this. Starts at 0, ends at 0, hits 0 halfway in the middle. In between those 2 points, it's going to go up to 3. In between the other 2 points, it's going to go down to -3. All right, so now I've graphed everything except for the left movement. So if I want to move left pi, and 2 boxes equals pi, then I'm going to have to take each of those points and I'm going to have to move each of them left 2. So I'm going to cross this one out, move it left 2. Cross that one out, move it left 2. Cross it out, move it left 2. Cross it out, left 2. Cross it out, left 2. And then I'll just go ahead and connect the dots that I have. Now, if you want to do some math art, you can actually draw both of these, and it makes some pretty cool looking graphs. So then you would just label which one is your parent graph and which one is your graph where you actually did all of the transformations. But you don't have to draw all of them. You could just draw the green one. That would be fine. All right, let's go ahead and try this one. We're going to do y equals negative sine of 3x minus pi halves plus 1. Okay, so again, they did not put the number in the front so we could see what the period was very easily. So the x is kind of like theta in this case, and we need to get that 3 pulled out into the front. So I'm going to think of it as like a GCF of 3. I'll go ahead and leave my negative sign. Put the GCF of 3 in the front, so the x is all by itself. And then if I take 1/2, because that's a 1/2 in front of the pi, if I take 1/2 and divide it by 3, it actually gives me 1/6. And so this would be minus pi 6 with a plus 1 on the end. All right, so all I'm going to do first is I'm going to deal with my period and I'm going to deal with my amplitude. So the period normally is 2 pi. It's going to be divided by 3. So the period is going to be 2 pi divided by 3, or 2 pi thirds. The amplitude is just 1. And when I go ahead and draw my intervals, I just have to keep in mind that once I'm done, I'm going to be moving right pi 6, and I'm going to be moving up 1. So I have to make sure that my intervals are set up in such a way that that's an easy thing for me to do. So 2 pi thirds I'll go ahead and I'll do every boxes as pi thirds. And the reason that works well is because then this would be pi 6, and then 2 pi 6, 3 pi 6, 4 pi 6. So that means when I go to move it right pi 6, that's going to be a pretty easy thing for me to do. With the amplitude of 1, I just want to make sure that I have room to shift the whole graph up 1. So I'm going to go ahead and say this is 1 and this is 2. Negative 1, negative 2. Okay, so before I do my left and my right movement, my up and my down movement, I'm just going to do the period and the amplitude. So I'm going to start at 0, end at 0, hit 0 halfway in between. Since this is a negative graph, between the first 2 points, I'm going to go down to negative 1. The second 2 points, I'm going to go up to positive 1. So there's like my amplitude and my period all graphed out. Now I can go ahead and shift every point right pi 6 and up 1. So right pi 6 means I'm going to go to the right 1 box. Up 1 means I'm going to go up 2 boxes because that's how I set up my intervals. So right pi 6, up 1. Right pi 6, up 1. This one, right pi 6, up 1. Oh, they're kind of landing on each other. Right pi 6, up 1. And then right pi 6, up 1. And so that's what my graph should look like.